Hello everyone, amateur meteorologist. First and weather here. It is my 2019-2020 winter forecast time. It is the middle of October and I finally have a preliminary winter forecast for this year. And keep in mind that this is a preliminary winter forecast, so I will be having a second update sometime around November. But I do have to say right now I am moderately confident for what's going to happen this winter. And I certainly feel like this could be an interesting year, especially for areas east of the Mississippi, and I'll get more into that later into the video. So first off, however, let's go into what happened for 2018-2019, and these are the temperature anomalies for the months of December through March 2018-2019. As you can see, the winter was predominantly characterized by warmth in the south, and cooler than average conditions in the northwest. For example, just east of Idaho into Montana, Wyoming, North and South Dakota, while we had predominantly ridging in the southeast with that big high right here. And this was particularly predominant in the month of February, where we had really dry and very warm conditions in this entire area right here. We really limited the snowfall for areas along I-95, while areas in Montana, North Dakota, and South Dakota had really cold temperatures overall, and quite a bit of snowfall this last winter also. And if we go to the precipitation values, you can see that the main wet spots were right in California. All right, and then you also had this area right here in the south. It's quite a bit of rain. And one of the main storm tracks that we had that last winter was where the storms would go mostly like this, all right, or more like this. And so that provided a lot of precip in these areas and also made things quite wet here and quite snowy here. And other winters that we've had, the storm tracks have been further to the south. For example, in the winter of 2013-2014, where we had a lot of storm tracks going like this, and this allowed for that snow to move further east. While last winter, it was about 200 miles inland, called Appalachian Runner Systems, where we had a much more inland-oriented winter track, which really helped to limit snowfall for areas along the I-95 corridor. So, factors to consider this winter. First off, the El Nino, La Nina, or La Nada scenario. And excuse me, this is a spelling error. This should be just the NINA. But the other thing is the Pacific Ocean, what's going on in the Pacific, the sea surface temperatures, then the Northern Atlantic, the QBO, soil moisture, Siberian snowfall cover, and solar activity. Siberian snowfall cover will be talked about later in my November winter forecast, because right now it still is, we are in the month of October, so I'll have a better idea on that later as I do my final winter forecast sometime in November. But as of now, I will be going through all these factors right here, and I'll be adding this one later. So, the methods I'm using to create my winter forecast are number 1, teleconnections and sea service temperature values, number 2, analogs, and number 3, climate models. And I'm using all three of these combined and also my intuition and just my overall general knowledge to formulate my forecast for this winter. So, let's get started. Let's start off with the ENSO, and it's looking quite likely that this year we will be in a warm ENSO, where the sea surface temperatures in the Nino 3.4 region, the area most commonly used for these forecasts, as you can see right here on the left-hand side, where it's between 0.0 and 0.5 degrees above average. It's not above 0.5. If you're at above 0.5 Celsius for 3 months or greater, then you are in an El Nino, and it looks quite likely this winter we will not reach the El Nino state. For example, this is the December, January, February forecast, and as you can see, we are just below that 0.5. A lot of the models also have it slightly lower. And it looks unlikely that we will be in a cool ENSO where temperatures are in this area right here. It looks more likely that we will be in a warm ENSO this winter. And as you can see, we have the dynamical average, as the statistical average, which all are in this ENSO category. Now, if we look at the sea surface temperature anomalies, this is as of October 4th. As you can see, we have that nice cool pool right here, then an area of above average to below average water temperatures, so more of a mix. And that is more characteristic of ENSO conditions, where you have a mix of warm and cooler waters rather than just predominantly warm or predominantly cold. And also, one thing I want to point out is that the core of the above average sea surface temperatures are focused in this area right here. So it's a more central based Pacific ENSO this winter, and that could also play a key role. And as of now, if this trend continues, we could see a Modoki ENSO, and this completely changes the game. It could really increase the impact the ENSO has this winter, since Modoki El Niños or ENSO conditions do tend to increase the chances for cold and snowy conditions in the eastern half of the country. So this definitely is something to watch. And here's another graph that shows these statistical probabilities of ENSO conditions. As you can see, for December, January, and February, the highest likelihood is that we see a neutral state this year. The second highest is El Nino, and the lowest is La Niña, around 8%. And here is another model chart. This is from the NMME, and for December through February, we can see that we are well in that ENSO 0 to 0.5 range. Some of the models are actually taking it above the ENSO line, but I do not think this is going to happen. I think we will primarily be in this area right here. And here's the CFS forecast. Again, same thing, right around that 0.3, 0.4 range. So I think we will be in a warm ENSO, but not quite enough to see El Nino conditions. So what do we typically see during ENSO winters? Well, typically we have a more trophy polar jet stream in the eastern part of the country with ridging in the west. And then we also have a more active subtropical jet stream, which makes things quite wet in the southeast and also the mid-Atlantic. And that can really make it an ideal scenario, for places like the mid-Atlantic, Northeast, and even Midwest, where you have these storms just go right up the coast and provide pretty nice snows for these areas. And with the cold here, it really is just a good winter for the east, typically, which is what happens during an ENSO, while the southwest and also lower portions of the southeast remain quite warm. However, for the winter of 2019-2020, when you have ENSO conditions, it typically means that other factors such as the NAO, the PDO, and the QBO can have much greater importance. Unlike other winters where you have a strong El Nino, a moderate El Nino, or moderate La Nina, when you have ENSO conditions, the impact or the significance of that teleconnection goes quite down, and you have it basically overtaken by other teleconnections such as the NAO, the PDO, and the QBO, and so it becomes even more important in winters like these to look at some of the other factors, while in other winters you can kind of just go off of what the Pacific is looking like. In these winters, you really have to pay more careful attention to other things around the globe, such as the Atlantic, and so on and so forth. And also, I touched upon this earlier, the possibility of a Modoki El Nino this winter. I will be getting into that, or ENSO this winter. I'll be getting more into that later this year, particularly around November, and I'll be noting if this trend continues as we go closer and closer to winter. So now let's switch to the PDO. And the PDO is also quite an important indicator of how the winter can turn out. And again, if you can't get the Pacific right, you really cannot get the United States right for any seasonal forecast, because everything is flowing from west to east, right? And so the Pacific is a great influencer on what happens in the entire United States. So it's very important to get the Pacific down correctly. Oftentimes, everything can be right in a winter forecast, but then when the Pacific is wrong, everything just completely busts. So it's very important to get this area right. And as you can see, we have unusually warm conditions in the Pacific right now. You have a very warm blob right here and right here, and this was actually a key characteristic in the winters of 2013 to I believe 2015, and those were winters where we had very cold conditions in the east, very warm conditions in the west. And one of the biggest reasons for that was because this extremely large area of above average sea surface temperatures sort of influenced a ridge right here, which then forced troughing down into the eastern part of the country. So the Pacific can definitely be a great influencer and a significant influencer of the weather in the United States. And since sea surface temperatures are looking so warm, it's possible that we see a positive or a slightly positive PDO this winter. While there isn't that signature characteristic of that horseshoe and the warmer waters right here, it definitely does look like we could see a slightly positive PDO, and if anything, just ridging being amplified by this area of warmer waters right here. Now here is a typical cold phase PDO or negative PDO where we have cooler than average waters hugging the coast and warmer than average waters in the central Pacific in a horseshoe shape. And the same thing is, the opposite is true during a warm PDO phase where we have warmer than average conditions hugging the coast and cooler than average conditions in the center of the Pacific. And this is not what we're seeing for this year. We just see mostly a warm blob. The Pacific in general is very warm, and so this could essentially take the shape of a warm PDO phase with those warmer waters right here kind of influencing that ridge to take place in the west and that trough in the east. Now here's the NMME forecast, sea surface temperature forecast for the months of December through February. And as you can see, it's still showing that extreme warmth around Alaska, warmth here, and so that definitely indicates that we could see some amplified ridging for this winter. Same thing applies for the CFS forecast, and in fact, it has a more classic PDO shape with that more horseshoe shape, cooler waters in the middle, and so it definitely looks like that there is a good chance we could see a slightly positive to a positive PDO this winter. However, the one issue is, for some reason, the PDO has been registering positive, then negative, then neutral again. So it definitely bears watching, but I'm pretty confident that this winter we will end up seeing slightly positive conditions. But I do believe the bigger factor will be just that unusually warm area of waters around Alaska to the south, west, and north, which could really help amplify that troughing in the east, bringing down that colder air from Canada. So, in summary, I think there will be a slightly positive PDO, but the bigger factor will be the area of warmer waters south of Alaska, and that will help, again, support ridging in the west and troughing in the east. So now let's switch gears to the NAO, the North Atlantic Oscillation. And this is a table of the teleconnection values for the past few months, and as you can see, from 2018 December through essentially April, we were pretty positive, strongly positive in some instances, for example in March, but then after that we just completely switched to negative since May, and we are starting to see that maybe that trend is starting to end. We're at negative 0.16, finally going back to the neutral area, and so it definitely looks possible that we could be going now to an extended overall positive phase, and that could impact our winter for this year, as the NAO could remain positive for the first half of the winter before turning predominantly negative and favorable for the second half of the winter. And one thing to note is the NAO is very tightly linked to the AO. So when the NAO is negative, the AO is generally negative. So those things go hand in hand. And so that will definitely be an influencer in my forecast. And as you can see, this is the NMME sea surface temperature forecast again. You can see for the NAO, you don't really have, it's not really showing that warm pool south of Greenland that's typically characteristic of a negative NAO. So definitely there is some uncertainty with this, but I do believe we will eventually transition to a predominantly negative NAO, especially as we go into February for this winter. And this is the CFS forecast showing more or less of the same thing. So now, switching gears to the QBO. And again, like I said, this winter, these things will be a much bigger factor. And I've enlarged the past 3 years. And as you can see, the QBO is now starting to fall to the negatives. And so typically speaking, it's generally confirmed that negative QBO values or easterly QBO values tend to favor troughing in the east, cooler than normal weather in the east, and warmer than normal weather in the west. However, new research has shown that it's actually not really what the value is, but what the trend is. And so the biggest indicator of below average temperature anomalies for the eastern United States was falling QBO values from the positive to the negative, which helped to increase the likelihood of seeing below average conditions for the eastern half of the country. And that's exactly what we're seeing now. We were at 9.22 and then 9.41, and suddenly this dropped to 6.85. So I think this winter we will be in the middle of a transition from slightly positive to then eventually negative values in February, and that I think could be very favorable for promoting blocking and promoting cooler than average weather in the eastern part of the country. And again, this is a map that shows what I was discussing in the last slide. Down here on the x-axis is QBO change. As you can see, when you have the QBO decreasing, you tend to have a greater likelihood of winters that are below average in terms of average temperatures for the eastern United States, right here. So, in summary, the QBO trends can often be important rather than the actual values. And for the winter of 2019-2020, the falling QBO going into neutral to the negative phase looks likely, which promotes below average temperatures in the east. So now let's talk about soil moisture. And so this can exaggerate persistence patterns and influence areas of persistent troughing and ridging. And so currently, we do have a pretty good drought in the southeast. Luckily now, as of recording this video, this has significantly reduced. However, if this drought does reemerge, which looks unlikely at this point, it could enforce or reinforce that sort of jet stream to arc northward once it reaches the eastern half of the country. That could promote the colder weather in the west and stormier and snowier weather in the west. But as of now, this is something that could really snowball, ironically, this winter for the east and make things really warm, make things really wet and not snowy. But if you are a snow lover, the good news is that the drought is looking to be on its way out for much of the south, which will really help to decrease the chance of a persistence pattern formed by soil moisture, where you see the jet stream kind of troughing to the northwest, or troughing in the northwest rather than the east. Now let's talk about solar cycles. There has been some data and research that links solar minimums, where we have a very low amount of solar activity on the sun, to increased high latitude blocking, and there is some potential truth to this. For example, when we do have solar minimums, we have had multiple very cold and snowy winters in the east. For example, the winter of 2009-2010, the winter of 93-94, when there was also a solar minimum. And for this winter, we are approaching the solar minimum of solar cycle 24. And so this is the solar cycle 25 preliminary forecast that goes like this. And as you can see, for the winter of 2019-2020, we are right down there for the solar minimum. So this could promote some high latitude blocking. There is some correlational data with this. Again, this is all correlational, but when we do have these solar minimums, there is increased consistency of high latitude blocking, which promotes colder weather in the east. So now let's look at climate models. They can be quite unreliable when forecasting winters. They can downright be completely wrong. And oftentimes they do have a warm bias, but sometimes they can be better in helping understand the overall atmospheric picture. And it's important to point out or observe prominent model features that consistently show up. So here is the CFS V2 geopotential height and anomaly forecast for December through February. And as you can see, it is kind of showing that jet stream being really strong and active, and then sort of ridging out into a split flow right here, and this would promote warmer conditions in the west. And then you can kind of seeing it meeting up right here, all right, kind of condensing back together, and this would support the idea of storminess in these areas right here, and it would also support the idea of troughing in the eastern part of the country. Now this is the CANSIBS 500 millibar geopotential height and anomaly. And it's the same thing, same forecast for December through February, just a different model. And you can really see kind of the same thing. And the forecast for ridging in the west, right? That jet stream kind of goes in that split flow, and then that troughing here. And so both models are indicating in the upper air pattern that we could see troughing in the eastern part of the country and ridging in the west. And when you look at the actual temperature anomaly forecast for the CFS, which I showed earlier, it's actually showing a blowtorch for the entire country. Warmer than average conditions in the east and warmer than average conditions in the west. So it really is more important sometimes to look at just what the overall atmospheric picture up in the higher altitude the model is showing, because sometimes you can just get a better idea of what could be going on this winter. And one important trend to note is that both models are indicating ridging in the Pacific Northwest, especially in these areas right here, and that could really help to promote the initiation of troughing in the east, which would keep things cool and stormy here, and then also dry and hot here. Definitely something interesting to note. Now, one last thing I want to talk about is trends. And so it's definitely important in meteorology to look at trends in climate data over the past decade or past 2 decades. And so here is the 1981 to 2010 average. And so these are the past 18 winters for December through February, all the winters averaged out. And as you can see, there is a distinctive trend. Areas in the Southwest, the South, and the Northeast and Mid-Atlantic have been consistently warmer over the past 18 years. How much of it being attributed to climate change, we don't know, but it definitely is interesting to look at. The one area that has stayed average, not warmed or even slightly cooled, has been this area right here. If you recall, this was the area that saw the coolest temperatures last winter. So it's definitely interesting to look at and to note. And it could definitely also impact this winter, and it definitely has played slightly into my forecast because it is very important to look into what history says and what the climate is trying to do and has been trying to do over the past few years. And it definitely looks like over the past 2 decades or so, there has been the increase in above average temperature anomalies for pretty much the entire country, except this area right here, where we have seen a promotion of below average temperatures. And here's precipitation for the past 18 winters. And as we can see, we've pretty much had a drying trend for most of the South and the coastlines of the country, with a wetter than average trend and a trend for above average precipitation anomalies for the Midwest, parts of Wisconsin and Iowa, and also interior portions of the Northeast. So, after looking at everything, the teleconnections, the QBO, the NAO, the PDO, the ENSO conditions that are forecasted this year, I did find 2 analog winters: the winter of 1969-70 and the winter of 1979-80. And so these are the two winters averaged out, and as you can see, these are the temperature anomalies. We did have warmer than average conditions in the West, quite warmer than normal, while the polar opposite is true for the East, with below average temperature anomalies. All right, and so this is quite significant because with both years averaged out, we can see that there is a strong indication for ridging in the West, troughing in the East. This is quite clear. You can see that distinct pattern right here. There's cooler conditions in the East, warmer conditions in the West. So this definitely is interesting. And if you are a snow lover, this is good news, because when in 1969, in the winter of 1979, where you had very similar conditions to what I'm forecasting now, and in fact, for each analog, 3 of the 4 conditions are met in terms of the teleconnection, which is including the ENSO, the PDO, the NAO, and the QBO. So again, very similar winters. And in those winters, this is what happened, averaged out. So again, very interesting to note, and definitely good news in the East if you're a snow lover, and bad news in the West if you want a cold and snowy winter this year, for sure. Now here are the precipitation analogs. As you can see, definitely wetter along the coast. I disagree with this for this year, and I'll explain that later. And then also drier in the Southeast and Midwest. So here is my 2019-2020 winter forecast. This is my preliminary winter forecast again. And so without further ado, here is my temperature outlook for the months of December through February. As you can see in the red right here, I am forecasting well above average conditions, while in this orange color, I'm predicting slightly above to above average temperatures. In this white area, I'm predicting average conditions. In this blue area, slightly below to below average. And finally, in this dark blue, well below average temperatures. One thing I want to note is that I do believe this will be more of a north-oriented winter for the eastern part of the country, where the brunt of the cold will be in this area right here. Alright, while these other areas in the blue will just see slightly below to below average conditions. And I think one of the main reasons for that is because in the beginning or initial stages of the winter, the jet stream will be more like this, alright? Making more of that cold concentrated in this area. It will be more of a zonal flow in the east. But then as we go through January and then eventually February, I think things are really going to change, where we have the jet stream going more like this, right? So the winter will finish really strong in these areas right here after January 15th. But I think below that, the main show is going to be in these areas right here. And so because of that, again, I do feel like the worst of the winter will be somewhere in this area right here with the well below average conditions, the perfect storm track going like this. And so that's why I have the brunt of the cold in this area right here. Now, moving on to precipitation, I believe that the west is going to be quite dry this winter, due to that ridging in place from that jet stream being amplified in the west. And I do believe this will cause below average precipitation in this brown area, and in the orange area surrounding it, slightly below average conditions. In the average, or in the white, I think there'll be average precip, or about 8 basically equal chances. In the green, the light green, lime green, I think will be slightly above precipitation, and in this darker green, I think there will be above average precip due to that frequent troughing right here, making all these storms just ride along right here, providing ideal precipitation amounts for this area right here, coupled with the storm tracks going like this or like this. So I think this will really be a hot belt for above average precip this winter. Now finally, here's my snowfall forecast. I believe the real hot zone will be in this purple area, and one thing I want to note is that I only made the forecast for areas east of the Mississippi, and that is because I do not really have much expertise with areas in the west. I really don't know much in these areas when it comes to snowstorms and stuff, and that is because mostly I live in the eastern part of the country. So I just want to only make a snowfall forecast for areas that I really feel confident in. And so I do believe that in this purple area, there will be well above average snowfall due to this, because there will be people in these areas will be in the sort of the Goldilocks zone in terms of storm tracks. You'll have ones going like this, like this. You'll basically be seeing snow, or some snow at least, from every single track, basically. Whether it be a very small amount or large amount, you guys will really be in the thick of it this winter. And to the north and south, I think there will be above average snowfall. So looks like a very good winter for the east. It's going to be cold, snowy. The way it looks right now, especially into the Great Lakes region, things could get quite cold. And I think that really the heart of the snow is going to be in the Rust Belt, and also northern portions of the Mid-Atlantic, and also coastal regions right here. And I think with those frequent storm tracks going like this, I think even these areas and these areas have a good chance of seeing pretty good winter this year, cold and snowy. So again, very interesting winter. And I will have my final winter forecast sometime in November. But again, I'm moderately confident with this winter forecast. So thank you for watching. I appreciate for you guys taking out the time to watch this video. I hope you enjoyed it. If you have any questions, please feel free to leave them in the comment section below, and I'll get to answering them as soon as possible. And again, thank you for watching. I hope you're enjoying this video, and I'll see you next time.